Hi, everyone. Welcome to the webinar. My name is Sarah Weeder. I am going to be the moderator of the webinar today. I first of all wanted to thank everyone for registering and joining us today. We have a lot of really great information to share with you. The topic for today is migrating big data workloads to Azure Data Services. Our speaker is Tarun Agarwal. He is our data and AI specialist here at Motifworks. He is incredibly knowledgeable about all things data, all things data migration. So we're really lucky to have him presenting on this topic today. So at this point, I'm going to go ahead and hand it over to Tarun, and he's going to go ahead and get started.
Thanks, Sarah. Good morning, good afternoon, good evening, everyone, depending on wherever you are joining and logging on today. This is a great times with the technology. We are able to log in from any part of the world and attend anything which is going on. So thanks a lot for joining. So the topic for today's webinar is how do we migrate big data workloads to Azure Cloud. This is going to be a series. We are going to have a series of webinars around migration of big data and how do we leverage Azure Cloud's data services. This is the first webinar in this entire series, so let's jump right into the content. So quickly, a little bit brief about myself. Myself, as Sarah mentioned, I'm Tarun Agarwal. I'm data and AI practice lead at Motifworks. We help modernize data platforms for our customers and client. I personally am very passionate about big data, machine learning, AI technologies, and we are helping the modernized data platform using Azure Cloud to really enable our customers use cloud as a strategic data asset and really enable a data culture in the organization. Prior to joining Motifworks, I have been in various Fortune 500 companies in various leadership positions. I was at Lincoln Financial prior to Motifworks, where I was heading up the data management analytics practice and supporting retail distribution, wealth management, marketing, consumer insights kind of groups. And prior to that, I have organically grown in various other roles from Deutsche Bank, Bank of America, and other companies. So, quick background about who we are and what we do. So, we are Motifworks. We are a company headquartered in Maryland, right outside Baltimore. We are a company which is born in cloud, and we have a cloud first and cloud native approach. We are Microsoft partners, and if I take your attention to the bottom right of the screen, we have built our credibility by acquiring all the top level certification and accreditations from Microsoft. So we are proud to be a trusted Microsoft partner. We are a company which really helps our customers on infrastructure, application, and data. On infrastructure, we really help make a business case of adopting a cloud or migrating from their data centers, entire data center, specific applications, or specific servers, depending on whatever the use case may be. Really come up with the cloud adoption plan, the business value of embracing the cloud and how it can help the organization, and defining the architecture and governance to implement and start using the cloud. On application side of things, we help modernize applications by using cloud native services, microservices, container kind of applications to build connected ecosystems of various applications, whether it is SaaS based or cloud native applications. And on data side, we build modern data platforms by bringing all the data that they would like to use to really drive insights and value from data. The whole idea is as we move into more and more digitization and digital transformation, and as we are changing the application ecosystems and really working very closely with the customers, the data really plays a very important role. We can generate the insights from the data and put it back into the application portfolio to really have a connected ecosystem, and that drives the value to the customers, and that empowers the employees and also build the right product and services. That's really the value proposition of Motifworks. All right, so let's jumping into the content for this series of webinar. Like I mentioned, we're going to have a series of 4. This one is the first webinar. We are going to talk about how do we migrate big data workloads into Azure Cloud. And today we are going to cover about what is the ROI and the value that cloud platforms drive, what are the various approaches that we have for cloud migration, and how can we really plan this initiative, and how can Motifworks help? All right, so I think you probably most of people have already are tired of hearing all the buzzwords that people talk about. Cloud is a new oil and everything. I'm not going to use any of those things. Everybody realize the potential that data brings, and more business leaders are trying to leverage and invest into data analytics. But the challenge they are finding is the single most challenge is, how do I get ROI of all the investments I have made? So this is a research done by the Harvard Business Review, which really talks about 80% of the business leaders struggled from maturity of their data analytics platform. And another big pain point they have is how data silos are being created in the organization, and they are not able to maximize the value that we can get out of this platform. So what are some of the big data challenges? So before we even get into the big data challenges, you might have heard big data, is it real? And then a lot of people use it as a buzzword. My definition is slightly different from normal definition you probably hear. You will hear a lot of people define big data with the various V's, value, volume, variety, velocity, veracity, all those things. I think that the big data really is very simple than defining using all this V definition. And big data is any data that you want to process or you cannot process in time given the technology you have. That's really a big data. So today we are using 64-bit computers. Before that we were using 32 bits. But if you recall, when we started using computers in maybe in early 80s or something, they were 8-bit computers, and we used to work with floppy drives, and which can only hold 1 MB data. So any data which was more than 1 MB in those times was a big data. So it's not a new thing. It's not a buzzword. It's not something that the problem which is there with only large organization. Any organization can have it when they cannot process the data in the time that they have using the technology that they have at their disposal. That's really big data. So what are the challenges we have from big data? We can look at data challenges from a business point of view as well as technology point of view, because I'm sure both of them have their own views. The main challenges that we see from a business point of view is really not able to drive value and meet the business expectation. Businesses are growing very, very rapidly with all this e-commerce, and then the way that the companies are really trying to mature and have new areas of businesses. They have a lot of expectation that they want to leverage data with, and they're not finding it easy to drive value from their existing big data systems. There are a lot of data silos. I think these 2 points we just talked about also, which is very resonate nicely with the Harvard Business Review. Data is spread in silos because of various multiple technologies and tools are used in the organization. We were working with a marketing research company who are really providing the insights to all the retailers and manufacturers, what we found in the environment. But they were using multiple BI tools and technologies, multiple databases. They have MicroStrategy, Cognos, Business Objects, Oracle, Sybase IQ, you name it. They had a lot of these different technologies, and every technology was creating a silo and not really having the users really leverage the data together across the organization. And because of all the silos, there's a lot of investment and that goes, and also the data redundancy. That also creates a lot of complexity and increased cost, because all of these systems and technologies are very, very expensive technologies, and a lot of investment goes and which does not return the right ROI for the businesses. And it requires a lot of upfront investment. Another use case that we can talk about is a company which was running Hadoop, big data Hadoop technology. They had a Hadoop cluster of 25 nodes. They were trying to go for a new marketing campaign and needed to bring in additional data. For that, they needed additional nodes to support the new data workload that was coming. It requires upfront investment to buy those machines and bring it to use before the campaign can be run. And another big challenge is talent. talent is a big issue on both on the business side as well as technology side. But by having talent does not really mean you need technical resources and developers and architects to use the technology. Even the business users need to make themselves aware. And how do I make best use of this technology? So having the right talent in both sides is also a big challenge. From technology sides, with the growing business demands and this complex ecosystem of technology solutions, technology guys are just struggling to maintain these systems. And we have seen some of our clients spending 50 to 60% of their IT resources time just keeping the lights on. It's Hadoop technology. A lot of people have seen it. It's a complex technology, and it takes a army of people to maintain the Hadoop cluster and the nodes. If we are not able to keep up with the infrastructure because of the increased demand, and implementing governance is also another huge issue. So these are some of the main challenges that we see from a business and technology point of view. Performance, job management, those all are the ones that keeps, I think, all the IT managers up at night. That brings us with our first poll question, and I'll request Sarah if she can pull up the poll on everybody's screen, and let's spend maybe 15 seconds or so to go through this first poll question to really get a sense of all the attendees we have today. Where are they in their cloud journey? Are they already using cloud in some shape or form, or they have a mature cloud practice? And
All right, so it looks like just about everyone has voted. And what I'm seeing is that every single person is already using the cloud for infrastructure.
okay, that's great news. That's really encouraging to hear that already people are on cloud and using it for infrastructure. So that thing they are mostly at the right stage of leveraging cloud for data and AI kind of workloads. That's perfect. Thank you. All right, so if we talk about the on-premises big data analytics platform, the platform which are built using Hadoop technologies, which are becoming more often like IT debt. I think I just mentioned that about large amount of time from technology resources just goes in keeping the lights on. For 40 to 80% in some cases we have seen that the Hadoop administrators and Hadoop developers are just busy keeping the systems on, maintaining the servers, doing the patch fix and server maintenance and node maintenance and job maintenance, which and with Hadoop technology is also very expensive. The Cloudera distribution and automatic distribution costs are not cheap. So there's a rising cost of maintaining the Hadoop cluster, and which is becomes very hard to justify the ROI on the investment. And I think we just talked about this, unable to meet business agility. Businesses are growing very fast, and they are looking for technologies investments to give them the data that they really need to drive their businesses. And if 40 to 80% of the resource time goes in maintaining the system, they cannot meet the increased demand, and it takes longer for time to market the solutions. And Hadoop technology does not bring you the full capabilities of machine learning and AI that you really need to innovate. So these are some of the challenges with Hadoop, and it does not even end there. Hadoop technology by default is a complex technology. It was started by companies like Google and Yahoo, which was large organization, and they had a different large data problem. They were dealing with the web data, and they're really crawling all the web pages across the entire internet, and they needed technologies like Hadoop. Whereas when organization starts to embrace the Hadoop technology, they are finding it very complex, require large number of IT resources, and they cannot even it's very, very rigid. I think that I gave an example of to start a new marketing campaign, they needed to add additional machines in Hadoop cluster, and it takes time to add those machines, because otherwise you have to already plan out for your maximum workload so that you do not have to add machines at such a on-demand basis, which becomes inelastic and rigid and complex. And running Hadoop jobs are error prone. Every time Hadoop, I mean, any developer, I'm sure all the Hadoop developer out there can understand this point, is when there is a job failure that happens in Hadoop ecosystem, to restart the jobs and get the data integrity back in intact is a lot of tedious work and DevOps nightmare. So what's the solution? I think cloud. I think as we see, I think most of you people mentioned already that you are using cloud for infrastructure. I'm sure you are seeing some of the benefits that the cloud provides in an infrastructure as a service kind of a model. You do not have to worry about the maintaining and managing the infrastructure. You can spin off a new machine in cloud with a click of few buttons, and within minutes you will have a new machine ready. You do not have to go out procure those hardware, have a large investment going. You just click a few buttons, you spin off a machine and pay as you go model. It gives you the scalability. You can scale up and down on your compute power or storage, whatever you need. It gives you the speed. It gives you unlimited, almost unlimited capacity to scale up. And you can also go even also in a serverless model. If you do not have to, but if you want, you can go in a serverless kind of mode where cloud will use additional resources as it needs to process your workloads. And you only pay for what you are using, so it becomes a lot more cost effective and do not have to pay for large upfront investments. How do we, when we talk about Hadoop technology, how do we really migrate? What options we have and what approaches usually people take to migrate Hadoop workloads into cloud? So really, there are multiple options, but it boils down to the three main ways most of the people try to migrate their Hadoop workloads. Some companies go into the rehosting of their Hadoop clusters into cloud in an infrastructure as a service model. I think like some of you mentioned, probably all of you mentioned that you are using cloud for infrastructure. So you can spin off the Azure VMs and run your Hadoop cluster in Azure. It will give you, you will still have to maintain that Hadoop cluster. You will have your administrators doing the work of maintaining it, but from an infrastructure point of view, anytime you need to add new machines, it's not 3 months of waiting time to buy the machines, bring it to the use, configure them. You can get up and going, running very, very fast using rehost. In refactoring, Microsoft Azure provides you open source Hadoop technology in platform as a service. You're not just using infrastructure, you're also using the entire open source Hadoop running as a managed service using HD Insight technology. So you do not have to even worry about managing your Hadoop cluster. Microsoft will take care of it on your behalf. And another important part that you will get benefit is you will decouple the compute with storage. So you can leverage the data lake store to keep all your data, and you can scale up the demand of compute if you need more horsepower to process your workloads in using HD Insight. And the last one is a re-architect, basically reimagining the big data workloads in cloud using cloud native services. Thinking about big data beyond Hadoop. How can you use other technologies which are more optimized and cloud native and gives you limitless capacity to scale and a better overall experience and unify the platform. That's really re-architecture, and we'll talk more about how do we re-architect in the presentations today. I think I'm quickly going to go through this because most of that we have already touched upon, and I'm sure you are aware of the value proposition of cloud. You are going to move beyond infrastructure. You do not have to worry about just procuring hardware and putting it to use, and you can focus on your actually app dev and make your application development team, the Hadoop, the big data developers team, more productive. It gives you a better throughput because it's running cloud native and really using the optimized resources of the Hadoop technology of the Azure platform, and gives you the optimized cost because of running in a better throughput and performance basis. It takes faster time to market. We talked about it. The developers can focus on actually building the solutions, the data analytics solution, as opposed to maintaining and managing the cluster and the jobs. It gives you the innovation. It's Azure cloud is gives you full service machine learning, artificial intelligence, cognitive services, computer vision, everything in a unified environment. So you can leverage it, and you can really get the data in the hands of every single end user of the company and democratize the data inside. You do not have to provide the information into only the hands of the handful of people. It can go on the fingertips of every single user in the organization. So let's look at one of the case studies of a marketing research company who worked with the retailers to provide them the price optimization analytics. That company was using Hadoop technology in Apache Spark to run all their workloads and data pipelines and ingesting of the data into their environment. And they are finding it very, very hard just to maintain the environment, and also the performance was becoming an issue. So those that we help them migrate their Spark workloads into Azure Databricks technology. And just by moving the Spark jobs, which is very, Databricks is also running a Spark engine inside it. So just by moving their existing Spark jobs into Databricks, they saw 40% increase in the performance of their existing workloads, and their cost went down 20%. And they were also able to reduce a lot of data redundancy and save cost on the storage, as well as improve the data developers' productivity overall. So that's the benefit this retailer company saw working of removing their workloads in cloud and working with Motifworks. So that brings us to our second poll question. And Sarah, if you be kind enough to pull up the poll on everybody's screen to really understand how organizations are running their ETL workloads. Are they using any ETL tools, or they are doing custom scripting?
So I see about half of the attendees have voted, so I'll leave it up for a few more seconds so that everyone has a chance to vote.
Okay.
All right, perfect. So I'm seeing that most people use ETL tools like SSIS and Informatica, whereas some people are using cloud-based data pipelines.
Nice. Okay, that's good to know. Yeah, I think so ETL tools, Informatica, SSI, I think mostly people are using relational sources. And when we talk about big data, I think we'll see more about unstructured data and non-relational sources, how to bring them up. So let's dive into understanding of how can you do big data analytics into Azure cloud platform. So when we talk about big data and we talk about really using all the data available to the business users to generate insights from it, we are talking about not just relational data sources, we are also talking about non-relational or unstructured data, the data that is generating not only inside your organization, but also coming from outside your organization. How can we make use of all the data and generate the insights that is needed to drive the businesses forward? So we can run in Azure, process both structured as well as unstructured data, and we can run both batch versus real-time workloads. The tools that you will use to ingest the data, to bring the data in the Azure cloud, if you're running a lot of batch workloads, you will probably use something like Azure Data Factory. Azure Data Factory has a lot of connectors. You can run ETL as well as ELT using Data Factory, and you can certainly look into that. But it gives you a lot of connectors to directly connect to your sources and bring the data in a like ELT fashion and dump the data into Azure Data Lake Store. If we are using more of a real-time kind of analytics and ingesting data in a real-time environment like Apache Kafka technologies, which is a publisher-subscriber model, those kind of workloads in real time can be used in and executed in Azure Event Hub technology. And if you are running a lot of your jobs to ingest data, maybe Flume jobs or MapReduce for analyzing the data, or even Scoop jobs. So when you can replace your Scoop jobs in Data Factory and connect to your relational sources. But if you want to continue to use, like maybe for example, SQL Server data, you can use Azure Databricks also to run your Scoop jobs into Azure Databricks and bring the data into Azure Data Lake Store. So for storage point of view, Azure Data Lake Store is going to become the de facto source, whether for all kinds of data. And the data lake will be built using Delta Lake technology. So Delta Lake is a technology which was developed by Databricks company. So it's available to everyone in an open source Delta Lake as well. But if you are using Azure Databricks, which is a first party service running in Azure, it has a optimized Delta Lake engine from Azure Data Lake offer. And Delta Lake is, think of it as a Hive workload replacement. But the advantage that what Delta Lake gives is it is highly optimized and it is ACID compliant. So people who have come from relational background, they understand probably what the ACID stands for. ACID is atomicity, consistency, isolation, and durability. So it's going to keep your isolation level, even though it's a data lake and you are bringing in and all your data, but it will still keep your data consistency maintained. So think of a problem that currently a lot of Hadoop developers face, that if their Hive job fails, they have to go for cleaning up of the data and making sure that their Hive data table is updated. Those challenges are automatically taken care in Delta Lake technology because it is going to maintain the consistency of the data and keep it isolated from the new updates. And if it fails, it will not be reflected. So that's the Delta Lake. So all the data that is coming into Azure Data Lake Store, that will be built as a data lake using Delta Lake technology. And there are various concepts of bronze, silver, and gold kind of data lake environments where you can keep the raw data and then start to cleanse and remove the data anomalies to really create a gold copy, and by moving into an intermediate silver layer. So that's how you will build your data lake. So all your Spark jobs will come into Azure Databricks, and you can continue to process them. You can use Databricks to process your raw data and move them into silver and gold layer. And for doing your reporting analytics kind of workload where you need transactional level power, Azure Synapse Analytics is going to give you the MPP technologies of running your data warehouses workload. So think about Synapse Analytics is running your data warehouse, and Power BI is going to become the front end for all your reporting analytics. So like whether you want to create reports or dashboards, that will be given through Power BI. If you are trying to run your machine learning workloads or artificial intelligence, you can continue to leverage Azure Databricks. It's a unified platform that gives you not only data engineering jobs, but data scientists can use MLflow engine of Databricks to really run machine learning or supervised and unsupervised learning or deep learning kind of things. It also gives you the GPU enabled machines to run your cognitive services kind of workloads in Azure Databricks. So that's really the main thing of how are you going to use all of the cloud native services. All of these technologies are cloud native. They run gives you the on-demand scale, and a lot of those technologies support serverless. So you do not have to worry about, I have to deploy my VM here. Everything is running in a cloud native way. And possibly you can, if you want like Databricks, you can run with defined cluster nodes, or you can run in a serverless technology, both. So just summarize everything and give you the perspective of how this Hadoop workloads are going to be migrated to Azure. Gives you a snapshot of technology comparison. So all your HDFS data storage is going to move into Azure Data Lake. Your MapReduce jobs will go into Azure Databricks. Spark jobs can directly get migrated and run in Databricks. Hive will get translated into Delta Lake. All your Scoop jobs, like I mentioned earlier, either you can rewrite them to connect directly to the data sources, relational sources into Data Factory, or you can even run your Scoop kind of workloads in Databricks. Flume will go into Azure Data Factory. You can run Spark SQL into Databricks SQL. Kafka, we talked about, will go into Event Hub technology, which is also publisher subscriber-based technology and running in a cloud native way. All your HBase, the NoSQL database on top of Hadoop HDFS platform, will go into Cosmos DB. And to run your relational kind of workloads in Impala technology will go into Synapse. So that's an architecture to give everything in perspective of how your Hadoop on-premises environment will look like into Azure Cloud Services. And this is just one version of solution. There are definitely multiple ways we can do this. This is what we have done for one of our clients, where we moved their Hadoop environment, which is also running both batch and a Kafka workloads, and using Hive for all their data lake into Azure platform by converting their Kafka into Event Hub. Data Lake Store was used for HDFS, and Hive was replaced by Delta Lake. And their SQL data warehouse was converted into Synapse, and Power BI was replaced the business objects to give you a unified environment that's available on cloud. We have also developed a calculator, and it's available on our website. If you go to motifworks.com, on the homepage, you can see a calculator link where you can estimate your savings if you were to migrate your existing Hadoop environment into Azure Cloud. Again, this is based on the generic environment we have seen of running the workloads. I mean, we can, if we want work with you, we can give you the customized cost for your custom environment. But you will get a sense of by just putting very minimum information. It will ask for number of nodes you have in your cluster and number of jobs, Hadoop jobs that you run. Based on that, we will calculate an estimated saving. So in this example, I think I used 100 node cluster, and I think 500 jobs that runs in Hadoop multiple times during the day. It shows you that you can save up to 62% of overall cost by running this same workload into Azure Cloud. So this is Motifworks offer if you were to work with Motifworks to migrate your Hadoop workloads or even other big data workloads or data warehouse environment. We can come and help you with you and your teams and your company, and provide you a free 2-day workshop of coming and identifying your existing workloads, understanding the business value that these are provide, and the ROI the businesses are trying to generate, and give you a roadmap of how these new workloads are going to look like, with reference architecture, the migration plan, and the cost of running them in Azure. So that this at the end of this 2-day workshop, it will not only give you the reference architecture, it will give you the custom Azure cost of consumption and the savings that you can realize in your environment running your workloads. And along with it, we can also help you move your data, because data movement of HDFS into Azure Data Lake is the where the biggest of the work is going to go. It's not a magic wand. If you have large amount of data, it takes time. It depends on the network bandwidth we have. But if you are dealing with 100 terabytes or more, we can help you with some free data movement of up to 25 terabytes. That brings us to my last poll question for today. And Sarah, if you can bring it up on everybody's screen to really understand where people need the most support in their data projects.
So it looks like just about everyone has voted. It's about a 50-50 split between migrating existing workloads to the cloud and expanding data warehouse and reporting.
All right, that sounds about right. I mean, as I understood that pretty much everybody is using infrastructure, cloud for infrastructure. So I think they will probably need, they will have a need for migrating their data workloads to cloud. So it's completely understandable. Thank you, Sarah. All right, so that brings us to conclusion of our today's webinar. And I think we are doing pretty nicely on time. I think we have a few minutes left. And just a snapshot of the upcoming webinars. So I think, like I mentioned, it's a series of 4 webinars. This was the first one. The second one is coming a week from today, where we are going to talk about how do we build robust data platforms using Azure Databricks technology. And please, if you have already not done so, please register for the upcoming webinar. And we will have some good knowledge sharing of how do we use these cloud technologies to build your data platforms. So I'll hand it back to you, Sarah, to see if there are any questions that we can answer today.
Thank you, Tarun. So right now we're going to open it up for some questions. Tarun can answer any questions based on this topic, so feel free to type the questions into the chat box located on your screen. And if you have any other questions that you think of later on, or if you're reviewing the recording of this webinar that's sent out to you, you can definitely email Tarun later. His email is right there on the screen, and he'll be able to answer any and all of your questions at this time or in the future. So the first question that we have is, can I use Databricks to ingest the data in Data Lake?
Can I use Databricks to ingest data in Data Lake? That's a good question. Thank you for the question. Yes, you can ingest, you can use Databricks to ingest data. I think we just talked about if you are trying to replace your scoop jobs and it is connecting to relational data sources like SQL Server, you can use Databricks to connect directly using the Spark JDBC connector and directly bring the data into a data lake store. You will have to do data lake mounting, but that's possible. So yes, you can. Short answer is you can use Databricks to ingest.
Thank you, Tarun, and thank you for the question. Next question is, when should I use ADF versus Databricks?
All right, so I think related question, which is another interesting one. So like I think I mentioned this earlier. If you are trying to connect with relational data sources, like it's the example I just gave, SQL Server, and trying to bring the data into data lake store, you can write the Azure Data Factory pipeline and bring the data from source to the sink will be the target. Or you can run Azure Databricks. The question, I think the question to answer the question about when you should use one versus another, you have to look at from a cost point of view. Azure Data Factory, if you're doing data pipelines of just connecting to the source and bringing the data, it's going to be a much more cost effective than leveraging Azure Databricks and running your Python code or Spark jobs of bringing the data. So I think the cost becomes the deciding factor in cases where both supports the ingestion. I hope that answers the question.
Yes, that was perfect, Tarun. Thank you. And then another question that we have is, can I run machine learning in Databricks?
Can I run machine learning in Databricks? Yes, you can. I think I briefly touched upon machine learning, but let me elaborate. So the Azure Databricks give a unified data platform, a unified workspace for data engineers, data scientists, as well as data analysts to work together. It's a shared workspace. You can run not only your data pipeline jobs, like Spark jobs, you can also run your machine learning or artificial intelligence jobs in Databricks. It allows you to use ML Flow engine, which is a very optimized machine learning. It has all the libraries that you will need to run your algorithms, and you can it also gives you the specialized clusters that you can create to have the horsepower needed to process the data for machine learning. It gives you GPU enabled machines also in Databricks.
Great, thank you, Tarun. So we're kind of wrapping up here. So if you have any other questions, please feel free to email them to Tarun. As I mentioned before, the recording of this entire webinar will be sent out to you via email within the next 24 hours. So you can rewatch the webinar again, share it with your team, whatever you want to do with it. As Tarun mentioned, this is the first of a series of webinars. So there's 3 more webinars coming up. They are on the same day, Tuesdays at noon to 12:45 in the Eastern Standard Time. So feel free to log on to the next webinars, bring your team, and just if you are unable to join just by registering, you do have access to the recording. So that's kind of a bonus that you get just for registering for the webinars. And as always, Tarun and I are here. If you have any other questions, comments, anything like that, feel free to reach out to us. And we look forward to seeing you at the next webinar. Thank you so much.
Thank you, Sarah.